You might be wondering what computer programming is. Well, programming is the process of creating a set of instructions that tell a computer how to perform a task. Hello everyone, this is Miss Karen and welcome to Java programming class. In this section, we will be discussing the basic components of a computer, both hardware and software. We will also be giving a brief overview of programming languages and the program development life cycle. Finally, different number systems and conversions from one type to another will be discussed. What is a computer? It is a machine that performs a variety of tasks according to specific instructions. It is a data processing machine which accepts data via an input device and its processor manipulates the data according to a program. There are two major parts of a computer, the hardware and the software. The hardware is composed of tangible parts, while the software is composed of intangible parts. Let us discuss the hardware components of a computer. Let's begin with the central processing unit or the processor. The CPU is the brain of the computer. It contains millions of extremely tiny electrical parts. Examples of processor are Intel and AMD processor. Memory. The memory is where the data and instructions needed by the CPU to do its appointed tasks can be found. It is divided into several storage locations which have corresponding addresses, the primary and secondary. The CPU accesses the memory with the use of these addresses. The RAM and ROM are referred to as the primary storage. Random access memory or RAM. RAM is used to temporarily store information that is currently in use by the computer. This can include anything from Word documents to videos. Data can be written to and read from RAM very quickly. RAM is generally measured in GB or gigabytes. It is a volatile storage. This means that once the computer is turned off, all information residing in the main memory is erased. The more RAM you have installed in your computer, the faster it can perform. You can open and use more programs at the same time without slowing the computer down. Read-only memory or ROM. ROM is used to permanently store instructions in the BIOS or the basic input-output system or the boot program that tell the computer how to boot or start up. Information stored in ROM is known as read-only. This means that the contents of ROM cannot be altered or added to by the user. It is a fast memory. Data stored in ROM can be accessed and read very quickly. It is a non-volatile memory. This means that stored information is not lost when the computer loses power. Storage devices. Secondary storage devices are used to store data that is not instantly needed by the computer. They permanently store data and programs for as long as we need. These devices are used to back up data in case original copies are lost or damaged. Video card or graphics card. These are hardware devices that plug into the motherboard and enables the computer to display images on the monitor. They usually require the installation of software alongside the hardware. The software instructs the computer how to use the graphics card and also allows you to alter settings to change image quality and size. Sound card. Sound cards are internal hardware devices that plug into the motherboard. It allows the computer system to produce sound, but they also allow users to connect microphones in order to input sounds into the computer. Power supply. The power supply converts main AC to low voltage regulated DC power for the internal components of a computer. The fan and heat sink assist the CPU to cool down. Heat sink is made up of aluminum. Let's go now with the input and output devices. These allow a computer system to interact with the outside world by moving data into and out of the system. The input devices are composed of keyboards, mice, and microphones, while output devices are composed of monitors, printers, and speakers. These are examples of input devices. Let us now discuss the intangible part of a computer, which is the software. The software helps the computer perform essential operating tasks and enables the application software to run. It is kept on some hardware device, like a hard disk, but it itself is intangible. The data that the computer uses can be anything that a program needs. Programs act like instructions for the processor. System software. This is a software that a computer uses in order to function. Examples of system software or operating systems like Windows, Linux, Unix, Solaris, and Mac OS. Next is application software. These are all programs that users use to perform different tasks or for problem solving. Examples of these are utility softwares like Office programs, antivirus programs, internet browser, and image editing software. Peopleware. This is the most important part of a computer system. Computers operate using a combination of hardware and software. However, without user interaction, most computers would be useless machines. Peopleware refers to the role people play in technology and the development of hardware or software. These are the examples of peopleware. Compilers. The computer understands only one language, which is the machine language. It is in the form of ones and zeros. Since it is highly impractical for people to create programs out of zeros and ones, there must be a way of translating or converting a language which we understand into machine language. For this purpose, there exists compilers. Now, what is a programming language? It is a standardized communication technique for expressing instructions to a computer. Like human languages, each language has its own syntax and grammar. There are different types of programming languages that can be used to create programs, but regardless of what language you use, these instructions are translated into machine language that can be understood by the computers. Programming languages can be broken down into two types. First is the high-level programming language and low-level programming language. The high-level programming language is more user-friendly. It is abstract from low-level computer processor operations such as memory accesses. A programming statement may be translated into one or several machine instructions by a compiler. Examples are Java, C, C++, BASIC, and Fortran. Next is the low-level programming language. The terms high-level and low-level are inherently relative. Originally, assembly language was considered low-level, and COBOL, C, etc. were considered high-level. Many programmers today might refer to these latter languages as low-level. Programmers do not sit down and start writing code right away when trying to make a computer program. Instead, they follow an organized plan or methodology that breaks the process into a series of tasks. This is the program development life cycle. First is the problem definition. A programmer is usually given a task in the form of a problem. Before a program can be designed to solve a particular problem, the problem must be well and clearly defined first in terms of its input and output requirements. A clearly defined problem is already half the solution. Computer programming requires us to define the problem first before we even try to create a solution. Example is, create a program that will determine the number of times a name occurs in a list. Next step is problem analysis. After the problem has been adequately defined, the simplest and yet the most efficient and effective approach to solve a problem must be formulated. Usually, this step involves breaking up a problem into smaller and simple sub-problems. Example: input to the program are a list of names and names to look for, and the output of the program should be the number of times the name occurs in a list. Algorithm design and representation. Once our problem is clearly defined, we can now set to finding a solution. In computer programming, it is normally required to express our solution in a step-by-step manner. This is what we call an algorithm. It is a clear and unambiguous specifications of the steps needed to solve a problem. It can be expressed in either human language, such as English or Tagalog, and this includes flowchart and pseudocode. Flowchart is the graphical representation, and pseudocode is a cross between human language and a programming language. Next step is coding and debugging. After constructing the algorithm, it is now possible to create the source code. Using the algorithm as basis, the source code can now be written using the chosen programming language. Most of the time, after the programmer has written the program isn't 100% working right away. The programmer has to add some fixes to the program in case of errors, which is also called bugs, that occurs in the program. This process is called debugging. There are two types of errors that a programmer will encounter along the way. The first one is compile time error, and the other is runtime error. Compile time errors occur if there is a syntax error in the code. The compiler will detect the error and the program won't even compile. At this point, the programmer is unable to form an executable that a user can run until the error is fixed. Forgetting a semicolon at the end of a statement or misspelling a certain command, for example, is a compile time error. It's something the compiler can't detect as an error. Compilers aren't perfect and so can't catch all errors and compile time. This is especially true for logic errors such as infinite loops. This type of error is called runtime error. For example, the actual syntax of the code looks okay, but when you follow the code's logic, the same piece of code keeps executing over and over again infinitely so that it loops. In such case, compilers aren't really smart enough to catch all these types of errors at compile time, and therefore, the program compiles fine into an executable file. Flowchart. A flowchart is a design tool used to graphically represent the logic in a solution. Flowcharts typically do not display programming language commands. Rather, they state the concept in English or mathematical notation. Here are some guidelines for commonly used symbols in creating flowcharts. First is the process symbol. It is represented by a rectangle. It is a process of executing a defined operation or group of operations. Next is the input-output symbol. It makes the data available for processing, input, or displaying of processed information. Next is the flow line symbol. It represents the sequence of available information and executable operations. These lines connect each other symbols, and the arrowheads are mandatory only for right to left and bottom to top flow. Next is decision symbol. It represents a decision that determines which of number of alternative paths is to be followed. It is used in the if and else form of a code. Next is terminal symbol. This represents the beginning, the end, or a point of interruption or delay in a program. Next is the connector symbol. It represents any entry from or exit to another part of the flowchart. It also serves as an off-page connector. Next is the predefined process symbol. It represents a named process consisting of one or more operations or program steps that are specified elsewhere. Let's take a look at this example problem and how this problem is analyzed and translated into an algorithm. The problem is to create a program that will determine the number of times a name occurs in a list. Now we will identify the steps in solving this problem using an algorithm. First is to get the list of names. Second, get the name to look for. Let's call this as the key name. The next is to compare the key name to each of the names in the list. The fourth one, if the key name is the same with the name in the list, add 1 to the count. And lastly, if all the names have been compared, we will now output the result. Now for the flowchart, we will always begin with the terminal symbol to mark the start of the program. Next, draw an arrow down to get the input, which is to get the name list. After getting the name list, we will look for the variable called key name. Next is to create a process symbol that stores the value of a variable count. Next, we will create a condition using a decision symbol. If there are more names to the list and the answer is yes, compare it in the name list is equal to the variable key name. If yes again, add 1 to the count until there are still more names in the list and the name is equal to the key name. However, if there are no more lists, we will now display the count. Okay? Since it doesn't fit to the page, we will use the connector symbol and connect it to another symbol to continue the flowchart and display the count and then stop. In programming, we have number systems and their conversions. Numbers can be represented in a variety of ways. The representation depends on what it is called the base. The following are the 4 most common representations. First is the decimal. We normally represent numbers in their decimal form. Numbers in decimal form are in the base 10. This means that the only digits that appear are 0 to 9. Here are some examples of number written in decimal form. 126 and 11. Next is the binary. The base is 2 and the only legal digits are 0 and 1. We need to write the subscript 2 to indicate that the number is a binary number. Here are the examples of number written in binary form. Next is the octal, which is base 8. Only legal digits are 0 to 7. We need to write the subscript 8 to indicate that the number is an octal number. Here are the examples of numbers written in octal form. 176 base 8 and 13 base 8. And lastly, we have the hexadecimal, which is base 16. Only legal digits are 0 to 9 and the letters A to F. Lowercase or uppercase does not matter. We need to write the subscript 16 to indicate that the number is a hexadecimal number. Let's take a look at the summary of examples of converting decimal to its binary, octal, and hexadecimal form. In the next video, I will be showing you how to convert these numbers into their corresponding number system conversions. Once again, this is Ma'am Karen and thank you for listening and see you on the next video.